or right. Video 2 of the Forever Store series. I was so in the zone that I'm actually recording this video right after. Yeah. So basically what I was saying, this decoder thing, right? So let's get back because maybe you guys had a longer break than I. So we have the shake hands, right? Which we actually need to handle. What are we doing? This is going to be our read, our message read loop. So we're going to read from the connection. And actually, if you want to read, you need to do something like this. Let's say we make a buffer, which is a new bytes buffer, right? And then you could say nr is going to be, is it con read the buffer, right? Con read the buffer like this. And then let's just eliminate the error for now. Man, what's going on? And then we could say something like the message is basically debuff n, right? That's a message. But I wanna have something better. We're gonna make we are in the file, in this encoding file. We're gonna say type. We don't need an encoder, but we need a decoder. But I wanna keep these files in the same, keep these structs interfaces in the same thingy, in the same file. So we could say decoder is going to be an interface, and that's going to be decode an error. The question rather is, how are we going to do this? We could say decode any. No, it's going to be decode me a slice of bytes. No, we're going to say decode me an IO reader. That's what we're going to do. Decode me an IO reader and an any. I'm thinking we could actually make this. We could do so many things. Is this what we need? I think so, because we could do something like this, right? Instead of doing all the shenanigans, we're gonna delete this. And we're gonna say read loop. And actually, we could boot up a new one, but it is what it is. We're gonna do it here, and we're gonna say actually. The decoder is going to be a decoder. That's good. So we're going to say, in this case, we're going to say T decoder decode the connection into whatever type we want. For example, we are doing so many things at once. It's crazy. We're going to say type, this is going to be a placeholder, temp. There's going to be a temp, there's going to be a struct. There's nothing in temp because we don't care. And we're going to say, here in this case, we're going to say message. Wait, what's going on? Message is going to be and temp. And then we're going to say decode me the message. Right, that's good, and that's going to be an error. If the man, I'm thinking so hard that I cannot type. If R is going to be this, man, yes, no, that is not nil because my brain is already at the handshake because it's red. It gives me an error, and I'm going to say. We cannot actually log here, right? We cannot return. Are we gonna do a permadet? Are we gonna do a permadet connection where if he sends us something we cannot decode, we're gonna drop him? I don't think so. Maybe we could do cool stuff. We could say, for example, something like a len decode error, right? that's gonna be 0. And each time we have an error, we're gonna say length decode error plus plus. And if the length decode error equals 5 times or something, then we're gonna drop the connection. Hey, spam protection, something like this. I don't know. I'm not sure. I just came up with this, to be honest. I just came up with the shenanigans. It could be a good idea, actually. Man, I'm so... Today, it's my creative day. Not gonna lie, I'm creative today. I need to abuse it. So we're gonna say fmt print f. We're gonna say percentage. We're gonna say, actually, it's TCP, right? We could say TCP error once again. And then we're gonna say s new line error continue like this, right? There's no peers. Do we actually care? Could be connection. I don't care. Maybe we need to delete this login. I don't know. So we have this peer. We're shaking hands with a connection. Maybe we want a peer. Maybe we want a peer. Handshake. What's going on here? Handshake funk. Handshake with a peer. Man, what's going on here? Crumbles on my keyboard. I hate it so hard. I'm not gonna lie. T-shake hands. Why is this giving us issues? We don't have this function. Did we? What's going on here? Did we not rename this? What's going on? Oh man, I forgot something. Let me quickly do git init. Yeah, sorry guys, I missed actually committing the first episode, but I'm gonna do it right now. Git commit ip1 peer-to-peer lib, something like that, right? And then it's gonna be a couple more things in it, but hey, it's in the Patreon community, right? It's in the Patreon community. You guys understand. So we have the shake hands. That's good. That's good. Everybody's happy. Okay, cool. So we're gonna shake hands. If there is an error in shake hands, we actually need to drop this connection. So we're gonna say actually we should start the P loop with the Do we actually want already a peer? I'm not sure. Yeah, maybe we're gonna set something in the peer. We never know. My kids joining the YouTube studio, which is basically my living room. Wait, we need to do some money design decisions. New peer, shake hands. Let's shake hands with the peer. We don't care, right? We will see. If this is an error, we're gonna say close and actually return this thing. Man, why? So many lag in this VS Code. Var r invalid handshake equals errors new invalid handshake, and always make your errors low caps. Why is it not working? It is working. Could say add invalid handshake is returned if the handshake between the local and remote node could not be established. Established, man. All right. So we're going to say return add invalid handshake like this. Shit, we couldn't. Of course we can't. We are literally retarded. Damn. It was such a nice thing. The problem is, of course, we have this start except loop, and then we have this. No, man, we cannot have this because it's all just return, and we're gonna just log this out like this. Actually, let's tie it up. I'm going to say TCP error, TCP handshake error, like this. Very important that we first shake hands before we are going to decode here, right? Because in this handshake, it could be that we in the handshake function are actually reading from a connection, so we need to be very careful with this. All right, so. Yeah. Let us actually open up main. So we don't, do we have a decoder? We don't have a decoder, right? That's a problem. So we're going to say TCP transport. We need to have options, right? Because otherwise we need to have some options, to be honest. Type TCP transport opts. I'm going to be a strict, and we're actually going to say, listen, man, we need to do a lot of stuff. I'm not going to lie, this is going to take a lot of time. We're going to say that the listen address is going to be a string. We're going to have handshake func. Handshake func is going to be a handshake func. We need a decoder, which is going to be a decoder. Or make options like this, maybe, I don't know, or ops, or conf. I don't know, how do I need to call this? TCP transport ops, that's what it's gonna be. And then we're gonna say, instead of the shenanigans, we're gonna say give us the opts, which is gonna be the TCP transport opts. And then we're going to say shake hands. We don't need all of this, again, shenanigans. We're going to say that the opts, I mean the TCP transport ops is going to be the opts, like this. And then instead of, we can make this public. Listen other. Yeah, that's fine. It's all fine. Of course, T shake hands, that's going to be T handshake func, right? And then of course it's going to be T decoder, right? T decoder decode, yeah, like this. So if you go to main, we're going to say that the opts, TCP opts, right? We're going to be peer-to-peer, TCP transport opts, like this. We're going to say that the listen adder is going to be 3000. Decoder, that's a good question. I don't know. And the handshake is going to be a default knob handshake func. Knob handshake func, because we're gonna do no handshake, because it's always gonna be okay. So yeah, you could also say that the handshake func is gonna return a boolean if it's gonna handshake yes or no, but if it's return an error, you can have a better logging thingy. The problem is we don't have this TCP ops. We don't have this decoder, right? So if you go to decoder, encoding I mean, you could say type gop. Gop. Why am I laughing? A lot of people maybe don't is gonna understand this, but we are using gop so many times and I don't like gop. I actually like it, but it's not. Yeah, it is what it is, man. Gop decoder struct. Is that only a struct? Yeah, why not? Actually, we don't need this, right? So we could say func deck, which is going to be a gop decoder. Help. Do we need a pointer? Probably not, right? I mean, well, we could do that because then we could check if it's null. And anyway, we're going to try it without. It's going to be a gop decoder. We're going to say decode. We're going to decode the IO. R is going to be an IO reader. And we're going to have V is going to be an any. I'm going to return an error, right? So how are we going to do this? Actually, very easy. We're going to say return. Can we return? Yeah, we can. We can say gop new decoder. We're going to say the reader. And we're going to decode V. Hey, I cannot do it. It's that easy. I mean, it's plug and play, right? Then we're going to go to main. And then we're going to say, yo, the decoder. In our case, you can make any decoder you want. You could decode it in I don't know. You're the Bob Ross. If you want to extend this with your own decoder, man, go ahead and send me the code so I don't need to do it. Decoder is going to be a gop. A peer-to-peer gop decoder. Easy. That's what we're going to do. Yes. All right. So now we can actually do some cool stuff, right? We can test. All right, so we have this handshake, yes, decoder. What's going to happen? We have this message. This is not true. First of all, we need to make something that we can actually use in some kind of a channel, a message. If you want to send something over the wire, I'm thinking actually, how are we going to do this? Maybe we could do, nah, that doesn't make any sense. We could make a new file. I know it's a lot of files, but message go, we could say package peer-to-peer. We can actually refactor this and do whatever we want, right? I'm going to say type message RPC. Is it not RPC? Is it RPC? Actually, I'm going to make this even just more generic. Or just message, right? It's going to be a strict. And a message is going to be, or we make it like this, P2P message. Actually, why? Because it's already in follow P2P. Message. It's going to hold a payload, which is going to be a slice of bytes. Actually, it could be any. Is that payload? Do we need to know from who it comes? We actually always know, right? Or not? I mean, message represents any arbitrary message, any arbitrary data. Message holds any arbitrary data that is being sent over over each transport between two nodes, the network. And then we could say something like this. Message is going to be a message. We're going to decode this stuff. And after this, we're going to say fmt print f percentage v new line, the message. And we could say message. We're going to change this, right? But just for testing to see if this works. Actually. Does it make sense to make? Or we actually, let's do make run. All right, that's running. So we're gonna use or telnet shenanigans, localhost 3000. All right. So we have new incoming connection. Hello there. Ay, caraca. Or we handle, yeah, we handle it. Can it actually decode this in a message? Because we're not sending a message, right? Because the message is always going to be, unless we have something it cannot, GOP cannot encode this. That's the thing. Why are we decoding, by the way? Yeah, decode, right? Decode. Encoding, decoding. The problem is, look, if we do this real quick, damn, this was such a good idea, I'm not gonna lie. We could do like a buff, it's gonna be a new bytes buffer, and then we could say nr is gonna be con read the buff, right? If r, of course, is not null, we're gonna the error, and then we're gonna say like here, we're gonna say buff n. Can we do this? Okay, so this is basically something else, right? So we say telnet localhost 3000. Now see that's working, right? So we have this these messages, and the reason why a normal message not work is because it's GOP encoding. But hey, of course it's not gonna work because telnet does not send any GOP encoding. So how do we fix this? How do we fix this? Well, then we write our own encoder that works for normal connections, isn't it? I'm gonna comment this out. Make this message. Yes, that's what we're gonna do. We are actually insane. Trust me. We're gonna go to encoding, and we're gonna say func NOP encoding, just plain bytes. Yeah, that's a good idea. We're gonna make a type NOP decoder, which basically not gonna decode anything, right? And I think always providing something for your library, like NOP this, NOP that, NOP everything, it's interesting because users can just use this directly for their tests and all that stuff. So we're gonna say func. Actually, I'm gonna copy this whole shebang real quick, so I don't need to type that much. I'm gonna say this is gonna be a NOP decoder. Decode is all the same thing, and we're gonna say, basically, we're gonna say, actually, I'm gonna make a new buff. I'm gonna make a new bytes buffer like this, and then we're gonna say buff read. Can I do this? Is that a thing? It's probably, no, it's different, right? It's r read buff. Is that a thing? We can't. It needs to read bytes. Doesn't matter. We're gonna say that the buffer is gonna be 28 or something. I'm gonna read the buff. It's gonna be nr like this. If r, return r, and otherwise we're gonna say of course this any is of course is a problem, right? Ay caraca. I'm thinking actually because do we want to do the encoding in because we are in our transport, right? We are here in our transport, so making this is already hard coded. Isn't it? Because this could work like this, but I think we I mean, how do you decode everything into a message, right? Into a message instead of this any type. We could say it's going to be a message, and we're going to use this as a communication at all times. But what's the payload going to be? That's generic. That's depending on the platform. That's what you're gonna decode with whatever. We don't know. We actually don't know. We need to give the user the option, ourselves the option, because maybe depends on what we are gonna build. So we could actually do something like this. The message is gonna be. This needs a pointer, right? Because then we're gonna say the message payload. That's gonna be the buffer with this, right? And then we could actually delete all the shenanigans. Always make it a message. Oh, I think my caps lock is on. Right, and then we have this message, which is going to be the message. And yeah. Do we? Oh, wait. We need to make sure it's a knob. Or default. Default decoder, yeah. And then we're going to say, basically in main, we can just configure this. We're going to say this decoder is not going to be, it's going to be the default decoder, right? Like this. What's going on here? Yeah, I see. It's not going to be any. There'll be a message. Make run. Wait, V again. What's going on with V? Where is V? All right. So let's say telnet localhost 3000. Hello. You see now it's working, right? So we could give some messages, some random stuff, and then we can see that we are actually having a message with a payload. Yeah. And then what we could do before we're gonna pipe this into a channel, we are going to go to what's going on with TCP transport test. Yeah, that's broken, I guess. But you could go into TCP transport, and what we could do is if we take message, we could say we're gonna have a from, so we always know it should be a net adder. And then we could say something like we have this message, decode it, and then we're going to say message from is going to be com remote address, and that's not going to work. That's going to be a problem because, like we mentioned in the poker engine, it's not because if we dial somebody and his remote address is going to be the address he's listening to, and actually I want to have his listen address because so we can actually send back much more easy. But that being said, actually, for now it's good enough, right? We could say make run, and then we can say here, go run telnet local host 3000, and then we can say hello, right? And then we have this message, and it's coming from this other guy here, and that's the payload, right? And then we're going to send that into a channel, just a generic channel with a message, right? And everybody that's using the library, for the most part, we can then say, okay, it's a channel, we have this here, and we're going to handle it in the server, and that's going to be decoded. The payload is going to be decoded. Could be an any. Could be in any. We're gonna see. We're gonna see, because now it's a default encoding, which is basically plain bytes, but it could be that even those two messages are going to be sent over GOP encoding, over proto buffer, and then how we handle the inner bytes could be another encoding, decoding. I don't know. We're gonna see how this is gonna work. I think this is good for this video. I think the next video we are going to actually finish this up. We're gonna finish this complete up, so we can actually start with our key, with our disk storage thing, make a server, use our own library to connect, and everything is gonna be nice. Or maybe we actually gonna do our peer discovery and stuff also in this library. Not quite sure. We're gonna see. Thanks for watching, guys. Thanks for the support. Much appreciated, and I see you in the next video. Bye bye.